kinetics of a particle. Last time we already discussed on the basis, no basics or the introduction of our kinetics of a particle, that this is based on the Newton's second law, and then we are considering the dynamic equilibrium of a moving particle. Static equilibrium is the particle is not in acceleration, like in your static rigid bodies. Now we are dealing with particles that are moving. That's why we call it dynamic. And in equilibrium, because the summation of all the forces acting, the summation of all the vector forces acting on a specific body or a particle is just equal to the mass times the acceleration of that moving particle or object. Okay, let's proceed with our first example. So you have an example here, a 50-kilogram crate shown below rests on a horizontal surface. So we have a crate here resting on a horizontal surface, for which the coefficient of kinetic friction mu k is equal to zero point 0.3. So if notice that our coefficient of friction here is represented by mu k, or in kinetic, because uh, the particle or the object or the crate in this example is already moving. That's why we call this coefficient of kinetic friction. Coefficient of static friction if wala siya naglihok, but since the object is moving, then we have the coefficient of kinetic friction. The coefficient of kinetic friction here, or mu k, in the example is zero point 0.3. That is the coefficient of kinetic friction between the floor and the crate. So we have here, if the crate is subjected to a 400 Newton force as shown. So now force that is pulling our crate here, that is 400 newtons. Determine the velocity of the crate in 3 seconds starting from rest. Okay, let's write everything that is given in the problem. So we have a mass here that is 50 kilogram. This is the mass of our crate. What else? We have a coefficient of kinetic friction, mu k is equal to 0.3. Para asa man is mu k? Mu k, the coefficient of kinetic friction, is used to calculate our frictional force. Let's denote by that by the small letter f is equal to mu k times the normal force mc. Or that is equal to 0.3 times the normal force. In this example, what else is given? We have a force P that is equal to 400 Newton, but the force P is inclined 30 degrees. So please take note of that. And determine the velocity of the crate in 3 seconds starting from rest. Okay, so what else are given? Even yes, starting from rest. So it means that at time is equal to 0, our velocity is also 0. It's because it starts from rest. And then after 3 seconds, in 3 seconds, the velocity, we're going to find the velocity at 3 seconds. So sama na to is pag-solve. How are we going to solve this one? So the first thing that you're gonna do with this one, especially this type of problem, is you construct a free body diagram, FBD. So we have here along X and along Y. So in the FBD, we're going to plot or to put the forces that is acting on our object in this example. So some forces that acts on this object. We have a force P acting on this object that is equal to 400 Newton. And then that is inclined 30 degrees. What else? The We have the weight of the crate. So what is the weight? In SI, that is in Newton. So the weight of any object is just equal to the mass times the gravitational acceleration. So that is 50 kilograms. The mass of the crate is 50 kilograms, and the gravitational acceleration and SI is 9.81 meters per second squared, or equal to 490.5 newtons. So that is our the weight of the crate. What else? What is the other force that acts on this body? We have the what we call the normal force. the normal force is always perpendicular to the surface. So please take note of that. So if we have an inclined surface, then the normal force is always perpendicular. So since the surface here is horizontal, then therefore this is the normal force when plotted in the free body diagram. What else? What other force is acting on our object or the crate? We have you are given the coefficient of kinetic friction. Therefore, there is a frictional force acting on this body. But what is the direction of the frictional force? Take note that the direction of the object or the body is towards the right or towards the positive x-axis. This is also the direction of our acceleration. It means that the unbalanced force is moving towards the right. So, since frictional force is opposing the motion of the body, therefore it is always opposite to the direction of the object or the body. Since to the right man see acceleration of our body, then the frictional force is resisting. It resists the direction or the force that acts towards right. So therefore our frictional force F or equal to 0.3 times the normal force is moving towards the left. So this is our free body diagram. Next, what's the next at the bottom? Then we try to sum forces. So if you look at the quantum free body diagram, if you sum force along y, you have one unknown. If you sum forces along x, you have two unknowns. So in what way? If we sum force along y, the summation of forces along y is equal to, don't forget, the mass times the acceleration along y. Let's say all forces that is going upwards is positive. So forces that acts along y, we have the normal force NC positive because it acts upward, minus the weight of the crate that is acting downward, which is 490.5 newtons. And we have a force P, the y component of our force P, that is 400 sine 30 is equal to the mass times the acceleration along y, 50 times the acceleration along y. The acceleration, we know that the object is moving towards the right and not kuan, up or down. Therefore, the acceleration along y is 0 because the object is not moving along y. So that is just equal to 0. So we are left with not the normal force minus 490.5 plus 400 sine 30 is equal to 0. And then from there, we can solve that our normal force is just equal to 290.50 newtons. So we already have our normal force. Then let's sum forces along x. Summation of forces along x is equal to the mass times the acceleration along x. So let's say forces along x is positive. So what are forces that acts along x? We have the force P, that is 400 cosine 30 minus the frictional force 0.3 times the normal force NC is equal to 50 times the acceleration along x, or just simply A na lang because usa may acceleration sa taning on problem. So we have 400 cosine 30 minus 0.3 times the normal force. We can solve for the acceleration of the object. Our acceleration is 5.185. Unit is in SI meters per second squared. So nasolve na nato si acceleration ni object. Next, sa may buhaton na to, ipangita si velocity after 3 seconds. So sa next na to buhaton, we have an acceleration here. So since the force P is constant, the forces are constant, therefore the acceleration is also constant. So pwede na to magamit ang kinematic equation in this problem. So we have acceleration again is equal to 5.185 meters per second squared. We know that the acceleration is equal to the change of velocity or the dv over dt, or dv is equal to adt. Since this is constant, pwede na ito diretso mo gamit atong ano. We have the final velocity is equal to the initial velocity plus the acceleration times the time. Forget no napalit a given time, which is 3 seconds. Okay, the final velocity or the velocity at 3 seconds. We have the initial velocity, the velocity at 0 is 0, plus the acceleration is 5.185 meters per second squared, times the time that is 3 seconds. Makuha na din nato si velocity. After 3 seconds, that is just equal to 15.556 meters per second. And then you already got your answer. So even though no, please know that even though we are already in the kinetics of a particle, it doesn't mean that the equations that we learn in our kinematics cannot be applied. What we have here lang is that aside from the geometric property of the motion, there is already a force nga kuan, acting on the particles in our discussions. Okay, so that's it for the problem one. Now, first we wrote down the given 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 items, and then we determine what is being asked. And then afterwards, we draw the free body diagram of the forces that is or that we're acting on our crate or the object. So we have the weight of the crate or of the object. So don't forget that one. There is a weight, and then there is a normal force, not which a frictional force because it is specified here that there is a frictional force, and then there is a pulling force P, which is equal to 400 Newton. And then we're given here that initially it starts from rest. Our crate was starting from rest. That's why we have our initial velocity is equal to 0. And then we were asked to find the velocity of the crate after 3 seconds. So after plotting the FBD, we try to determine in which direction is the object moving. So we know that the object is being pulled towards the right or towards the positive axis. Therefore, its acceleration is also towards the right. So that's it. And then after the FBD, we try to sum forces along Y. So aron makuha na to C or masolve na to C, NC or the normal force. After determining the normal force, we proceeded with our direct summation forces along X. Again, no, the acceleration along Y is 0 because the object is not accelerating along the Y axis. The object is only accelerating along the X axis or horizontally. That's why 0 just a summation of force Y, but not on X. So as we sum forces along X is equal to the mass times the acceleration along X. So we have these values and then we arrive at the acceleration. So we got the acceleration first, so we can solve the velocity of the object or of the plate after 3 seconds. So after getting the acceleration, we know that that is the constant acceleration because the force P is not changing. The force P is constant. Therefore, ang pagbitad ani or the pulling the pulling acceleration of this one is also constant. That's why we use just the kinematic equation. Final velocity is equal to initial velocity plus the acceleration times the time. And I already got our final answer, the velocity of the crate. After 3 seconds starting from rest, that is being subjected to a 400 Newton pulling force, and is equal to 15.556 meters per